Hello and welcome to another Keysmash Studios tutorial. Today we're going to be going into the part 2 of our Race AI series. Today we're going to be looking into positions. Likely we won't get through all of it, but we'll try and we'll see where we end up. But this is probably the hardest part of Race AI, is getting all the positions to play nicely. It seems like it should be easy, but it's actually pretty difficult. So we'll try our best to muddle through that today and get us to a spot where we can finish this up and get the AI running around the track and looking like a race game. As always, if this video does help you, please consider liking, comment, subscribing, all that jazz. It really does help us out. With that said, we're going to jump right into this. All right, so the first thing that I want to talk about is off screen. I have put down some position colliders, and you'll see that I've actually put down a lot of position colliders. The idea being that we need a way to figure out where the players are as they run around the race. So as we show in our Photoshop file, let me drag this over here. In our Photoshop file, we have this start line, and we have them going around, and we have all the AI going between the different waypoints. If you missed that, check out episode 1. We talk about almost all of this stuff there. But we have all our 8 different AI going around to the various waypoints and so on and so forth. And we have this start-finish line. But the process of determining who exactly is closer to the finish line is a little bit more difficult than you think. Because, like, logically, we're like, okay, check laps. If our laps, we have one person who's a lap ahead of everyone else, they're in first place, so on and so forth. And then we just check the distance back to the next line. And that's good and all, but the idea of checking distance to the next lap point is actually not that easy. Because if we're all right here, right? Let's say in this layer we've got 2 AI that are right here. Oh, let's pick a different color than that so we can actually see it. We've got 2 AI that are right here and right here. And we're trying to figure out which one's in first. Well, we can look at it and say, probably this one's in first. But how do we go as a computer and determine which one is actually closer to this line? Because if we do a calculation and we say vector 3, that distance between these 2 objects, it will always return this object, right? Because this object in the 3D space is closer to the start-finish line directly here this way than the other object. So how do we determine position between these 2 races through code that goes all the way around and ends up at the start-finish line? And the answer to that is with a lot of colliders, basically. We can use waypoints. I've done it before, but I like colliders a lot more. It's a lot simpler. It's a little more intensive on the setup per map level, but it's a lot simpler on the code front. So I've set up colliders, and this is a lot of colliders. But basically, we have our start-finish line somewhere in this range right around here on our map. And as the racers go through, they'll run into the collider. It'll say, hey, or we'll set it up so it says, hey, we've run into a collider. Let's add a count to this. And then basically we can compare how many colliders have they run into. Are they essentially in the same position? Do we not need to update it? Or, this one's run into more colliders, so it's ahead of the other one, so on and so forth. Usually, when you do colliders, it works pretty well, so you don't actually have to, update it every frame. It's fast enough to the point where the player doesn't really notice it, and if they do notice it, it's probably just like, oh, where in the car does it measure, or something like that. So it saves us a little bit of resources, but what it saves us in resources, we probably lose in the fact that we're measuring all these colliders. So the net end result is that we have something that's probably a little bit easier to code than a more traditional waypoint-based distance calculation vector system. Not to say we can't do that with this system, but we can. So how do we get from our race AI here? So I have a race AI script. This is the exact same as our last episode. I haven't changed this at all. How do we get from this race AI script to link up with all these different colliders that I've created here? And, there's 46 of them. So how do we get these colliders, all 46 of them, to determine our position? Well, real quick, I do want to just note that if you have a section, if you're doing this collider system and you have a section of a race where you have like a U-bend or something like that, just pay special attention to these colliders that are on the very point of the U-bend. Make sure they go all the way out to the edges and are a little bit wider than your standard collider. We can run through this and we can, it's pretty fun. uh, but when we get to a section of the race that has this style of U-bend, you'll see that the racetrack is actually a little bit wider, and some of the AI might do a wide turn. So having a wide collider at a section where we have a U-bend like that, it really is going to help you. So in any case, back to where I was. How do we get these 46 colliders to tell us the exact position of the race car? And usually that's done through an on trigger enter. So I've set all these colliders to be an is trigger. You can see right here I've done a check mark. So is this a trigger? Yes, it is. We're not actually colliding with them. We just want to trigger some event to happen when we run into them. So what event do we want to happen when we run into them? So we need to have a function that understands that trigger. So let's do a void on trigger enter script, and you'll see that Visual Studios really nicely fills it out for us. So we have this on trigger enter script, and that's great, but we need to do something with this. Like, we can't just have it every time we collide with something like that has a collider that we go up. We have to specify exactly, we want these 46 colliders that are in our Unity file right here. So how do we mark them as we want these colliders? Well, the answer up here is in this tags. In these tags, we can set what all these colliders are to Unity. So we can come down here and hit add tag, and I am going to go to this plus mark, and I'm just going to create a new tag called RC for race collider. So then when I select all 46 of these colliders and I come to the tag thing, right in that drop down list there's an RC, and I can say all of these are race colliders, and that is all they are. Nothing else that is a potential collider down the road. I don't know, we might have like a boost path or something like that. That uses a trigger too. We don't want that to trigger and mess up our position. We want only these position colliders to be triggered as RC. So we've set them all as RC. So what can we do? We can say, well, if this collider that we've run into, this other game object, so if we grab that game object, this other game object, and we grab the tag of that game object, and we say if that tag is equal to RC, well, then we do something, right? What do? We have to make some type of system where we go through and iterate up. So let's go back up to the top here where we have our non-array variables, and we're going to create at least one more, probably a few more than that, but let's create two more for right now. Let's create a public, and I'll explain why in a second, a public int called colliders hit. And let's also create a public int lap. And we'll get to the lap in a bit. We want both of these to be public. So why are these two public? If you've been paying attention to the screen, you'll notice that up here in the top left, or over here on the right, I have a race manager, and it's just an empty script. I just created it and deleted the start and void. But eventually, we need to be able to compare where all the different AI are and determine position from where all those AI are. So eventually, we're going to need these to be public. And actually, for that matter, we need this this position one to be public. So just leave them public for now. We'll get to it eventually. So we have this number of colliders hits, and of course, when we create something up here, we need to instantiate it and start. So really quickly, we're going to come here and we're going to say, not public. Really quickly, we're going to come here and say, we're going to say our colliders hit, we're going to start that at 0, and our lap, we're going to start on 1, because we start on our first lap. So coming back down here to our on trigger enter, so anytime we hit this RC, this race collider, what do we want to have happen? Well, we just want to go up. So colliders hit plus plus increases the number of colliders that we've hit by 1. If we're at 0, it goes to 1. If we're at 1, it goes to 2, so on and so forth. So now, in our scene, if we pretend that we are a race car here, let's get those colliders back on. If we pretend that we're a race car here, and we come along here, and we're finishing up our race lap, and we're passing through, we're at collider number 44, 45, 46. What happens here? This is our start-finish line right here. I don't know if it actually is, but we're here. Actually, this is our start-finish line. So we're at 44, 45, 46. Boom, we're at our start-finish line. What happens here? Well, we need to make sure that when we hit this collider and we go back into the first set of the colliders again, so collider 1, 2, 3, we need to iterate laps, right? So let's go into our code and make sure that we have that. So we need a way to detect if it is an RC, and if that RC, like if that race collider is number 46, so if we hit that 46 collider, our collider's hit will be equal to 46. So we say if our collider's hit is greater than or equal to 46, well, then and only then we increase lap. So just like before, another plus plus. If we were on lap 1, now we're on lap 2. But we also need to just reset our collider's hit. So collider's hit is equal to 0. Then the next one we hit is the first collider of the second lap. It's important to note that this number here is specific to the racetrack. So if your racetrack has 37 colliders, it needs to be 37 there. So that's great and all. We have a basic way to determine roughly where the two AI are on the racetrack. Logically, we can say, hey, we come here and look at our map. We can say, hey, zoom out here. Well, it's a process. So we can look at our map and say, hey, we're on the second lap on our 20th collider. The computer can be like, oh, okay, they're right here. Great. We need to make sure that we do two specific things. First, we need our colliders to be close enough together that this is not noticeable by the human eye. If we put one collider here, let's say we take this collider here and this collider here. These are too far apart. If we're checking only here and only here for our position, then the human eye could notice, like while you're racing, like, hey, I just passed that guy, but my position stayed the same. So if we get everything in between those, human eye is not going to notice between here and here whether or not the position changed. So first we need them to be close, but also we need them to be accurate. So what is the one way that this system that we've created with all these different colliders on it, how can it fail? And the answer is if you go backwards, right? We're only checking if you go through and hit this collider, hit that collider, and then you turn around, you're still hitting colliders, you're still entering the collider box, so it's still incrementing right now. So how do we go through and make sure that going backwards makes it so you lose time or you're no longer in the front? And there's a lot of ways to do that, but probably the best way to do that is to make sure that we don't doubly hit an individual box. Because for the most part, this system is used for AI, right? They're going to do their best to move between waypoint to waypoint. And there might come a situation on one of these corners where they do like a little loop-de-loop or something weird, because sometimes nav mesh agents get a little bit wonky. So how do we make sure that if the nav mesh agent makes a mistake, that it doesn't mess up our positioning system? And the best way I can do that is to create a memory like a running memory of the previous waypoints. So I'm going to come up here underneath these non-array variables, and I'm just going to create a series of private game objects, and I'm going to call these collider memory 1, and then I'm just going to copy this whole line, and we're just going to paste this 3 times. And collider memory 2 and collider memory 3. So we have these 3 private game objects that are collider memory 1, 2, and 3. We need to double check before we iterate. So here when we hit this collider, we need to check, have we hit this collider before? So let's say, we'll put an if statement here. If this game object that we're colliding with, this other game object, is not equal to any of our collider memories. So we need to start with our first one. So if we grab our collider memory 1, so if our other game object is not equal to collider memory 1, or, actually this needs to be an and our other game object, same thing, we're just going to copy paste this because it's essentially the same thing. So if it's not our collider memory 1, and it's not collider memory 2, and it's not collider memory 3, well then we can have the code that goes through the colliders. So we can put collider hit plus plus in there. But then we need to make sure that we create this running memory. Each time you hit a collider, it should take that collider and make it collider memory 1. Collider memory 1 becomes collider memory 2. Collider memory 2 becomes collider memory 3. And the third one falls off. So logically in code, we actually need to do that in reverse. We want our third one to fall off. So collider memory 3 is equal to collider memory 2, right? Number 3, we forget. We don't need to worry about it anymore. Number 2 becomes number 3. And then number 1 becomes number 2. So we need to do that the same exact way. So collider memory 2 is now equal to collider memory 1. And then finally, we need to make our current collider that we just ran into, this current one, our collider memory 1. So collider memory 1 is equal to other.gameObject. So here we have 3 stored game objects, and every time we run into a collider, it just moves it back down the chain. So the one we run into becomes collider memory 1, the one that was 1 becomes collider memory 2, the one that was 2, that race collider, becomes collider memory 3, and we're good. If we're in our race and our AI comes through and, he's running, and runs through and, gets a little bit confused and then turns back around and then comes back, it won't mess up our position system. It says, hey, yes, you've run into a collider. Comes into the code, it says, hey, yes, you've run into a race collider. But that race collider is collider memory 1. So it can't be that. If it is that, none of this happens. So our collider's hit doesn't go up, which in turn does not mess up what we're keeping track of so we can determine position. So speaking of determining position, we'll probably have time to start that here. So let's go to our race manager, and we need to first pull in all the AI. So let's create a serialized field just like the last times, and this is going to be a private, and I'm going to call this script. So I'm going to create a private race AI script, but an array of those. So for all the AI, we're just calling the scripts that are attached to them, and we're just going to call this AI. That way we can have a reference to every single AI, and more specifically, we can grab their scripts, which is great because up here, remember when we created these things, we created them to be public. So now I can say race AI dot colliders hit and grab the number of colliders that they've hit, and race AI dot lap and grab the number of laps that current AI is on. So let's go ahead and create a compare thing, and then probably next time we'll do the logic behind the compare thing. So let's create a function here. And this is going to be a little confusing. This is why position comparing is tough, and it's really hard to logically follow. But we're going to create a function that gives us an int back, and we're going to call this compare position. And inside that, we're going to take in a race AI A and a race AI B. So in this function, we want to compare race AI A or race AI B, and we're going to see which one of them has the better position. And you'll notice that it is red right here. That's totally fine. It's saying we haven't returned an int. And the int that we're going to return is going to be based on the position that we want to say. So this will make more sense once I start going through this. We'll first say that the goal of this is to make as little calculating as possible for the computer. We want the race to be spending all its time running into colliders and spending all its resources really accurately measuring the race experience and the colliders in there. So we don't want to have a very intensive sort process here. So any way we can cut off a lot of this sort process, the better. So the first thing logically, we look at our race, is we first say, are they on the same lap? Right? You know, they are right next to each other, but has one of them lapped the other one? So in our code, we want to say if a.lap is less than, that's a capital M, is less than b.lap, well, then we want to return something. And I'm going to just return 1, and I'll explain why we're returning 1 and other things as I get more stuff put in. And conversely, we need to have the opposite, right? So if a.lap is less than b.lap, well, then we need to have a return function that gives us something else, and that's going to be -1. So the reason I'm returning 1 or -1 here is because I want to be able to call this later on and say, your position is this. You know, car A is position 2, car B is position 3. And I can say if A's lap is less than B's lap, position 3, we're going to +1 to that, so it goes up in our position. And if A's lap is I'm sorry, this needs to be a greater than. I just realized I put them both the same way. So if A's lap is less than B's lap, meaning that the B car has lapped the A car, well, then we want to say, return this 1 to the A car and say, your position is actually 1 higher than you think it is. It's at least 1 more than the B. And if our A lap is greater than the B lap, we want to say, you're actually ahead of that car. It's 1 less than you think it is. So that's one way that we can do that. So we first iterate through the laps. If the laps are less than or greater than, meaning that one way or the other are on a different lap, then we just exit out of this function right away. We don't care what happens after that. But as in most cases, the laps are going to be the same. So what do we do to make sure that we can calculate from that point on who's in the lead? So the next thing that we can compare that we created in our race AI is this colliders hit, right? We have a number of colliders, and we can determine roughly where they are on the course by the number of colliders that they've hit based on our logic. So if our a.colliders hit is less than our b.colliders hit, we're going to do something similar, right? So just like up here, where we said, hey, you know, your lap's actually less than that person you're comparing to, so you're 1 position further back than you think. Hey, your colliders, the number of colliders that you've hit, is actually less than that other car. They've hit the next collider, so their collider is 1 higher, so your position is 1 further back. So we're going to say position +1, which means here we put return 1. And conversely, on the other side, if our a.colliders hit is greater than the B dot colliders hit, our position's actually it's one spot better than what we thought it was, so we're going to return -1. Now here in our code, we have an option. If this was a AAA game or something like that, maybe not even. If this is a bigger game, meaning that you need it to be more precise, right here, we can put code for distance until next waypoint. If it's not, and you're fine with it just being like, hey, I just need to be able to quickly tell this, this is a demo. I just want to see, does this work at all? Then this is fine. So if we want to put that distance code there, we're going to need to create a waypoint, an array of waypoints and all that. So I might do that next week, but for right now, I'm just going to leave this blank. We've compared our laps, we've compared our colliders. So if those are both the same, we're saying, actually, both of your positions are right where we think they are. They haven't changed since the last time we've checked this. So we'll go ahead and put a return 0 here. We don't want to change our positions at all. We have a way to compare position between two different AI. So we have race AI A and B. It checks to make sure they're on the same lap. And if they're on the same lap, it checks to see if they have the same colliders. And if the colliders are the same, then and only then does it say your position hasn't changed since the last time we checked. Well, we haven't done that check thing, and looking at the clock, I'm guessing that I'm out of time to make this a reasonably sized episode. So probably next time I will go through how we calculate the position between the two and the logic of the update function that we have to follow to make sure that we're getting all the AI to compare to each other in the right way to get the position going the correct way. But today, we've got through the number of colliders that we're hitting. We've got collider memory to make sure we can't turn around and go a different way if we get confused, if we slide off the map, something like that. We also have, from our first time, all of our waypoints. You'll see that in the Unity thing I started but did not finish working on the inside-outside waypoints. By the start of next episode, I'll have all of those in there so we can start seeing all the different AI running around the racetrack and determining position. As always, if you have any questions, comments, or concerns about this, please let us know down below or join our Discord. We have a great help section in there. Lots of people who like game design. We're always more than happy to help. If this video has helped you at all, please consider subscribing. We're really working our way towards getting 1,000 subscribers. If you would like to, we stream on Twitch. Some of our company members stream on Twitch, so if you'd like to, give us a follow on there. I'll put a link in the description below. And we have an asset pack on the Unity store. You can find that in the description below, as well as our game that's out on the Android store. It's called Blast Off. It's a little 2D distance game. It's pretty fun. You should check that out. I'll put a link in the description below. We will continue this next week. Make sure we finish up this position system and get those AI moving. As always, I'll close by saying like, comment, subscribe, all that jazz. It really does help us out, and hopefully we'll see you next week.